Hey guys, today in this video we shall see about the concepts and analysis of arches. Let's start with the first question. A three-hinged parabolic arch has a span of 20 meter and central rise of 4 meter. The arch has hinges at the ends and at the center. So this is a three-hinged parabolic arch, and a train of 2-point loads of 20 kN and 10 kN, which are 5 meter apart, crosses from left to right of the parabolic hinge with a 20 kN load leading. So we have to find the maximum thrust at support. So we have two types of arches, two-hinged and three-hinged, and each type we have parabolic and semicircular shaped arches. So in this question we are going to learn about the three-hinged parabolic arch, and when train of load passing, so how to calculate the maximum thrust at the supports. Here the answer is option C, 31.25 kN. Let's see how to calculate that. They have given the train of loads as 10 kN and 20 kN, and 20 kN load is leading, that is, this is the first load. So when it is moving from left to right, we can see at crown position, when 20 kN load is at the crown position, then that will produce the maximum thrust. How? We can draw the ILD for horizontal thrust. So ILD for horizontal thrust is linear for three-hinged parabolic arch. So this is the concept behind this question. So ILD, that is influence line diagram for the horizontal thrust for the three-hinged parabolic arch, will be given like this. So the maximum will be at the ground level, and that ordinate will be L by 4H. The ordinate for horizontal thrust at the maximum height will be L by 4H. Then what will be the ordinate at this at below 10 kN load? Then we can find using similar triangle concept. So if at 10 meter the maximum ordinate is L by 4H, then at 5 meter length what is the ordinate? If we find a ordinate at this level and multiply that ordinate with 10 kN plus L by 4H into 20 kN, then we can find the answer as 31.25 kN. The concept here is the ILD. ILD for horizontal thrust for a three-hinged parabolic arch is linear. So we have to draw diagram like this, ILD, with the maximum ordinate at the ground level as L by 4H. So this is the concept behind this question. Now let's move on to the next question. A three-hinged symmetrical parabolic arch. Again, we are going to say about the parabolic arch, three-hinged parabolic arch only, having a span of 20 meter and a rise of 5 meter. Carries a UDL of 2 kN per meter for the whole span, like this. For the whole span, the UDL is 2 kN per meter. We have to find the bending moment at quarter point. So here we have to find the bending moment at quarter point. In the previous question, we studied about the horizontal thrust. Now we are going to see what is the bending moment and how to calculate what is the concept behind those things. Here answer is 0, because the bending moment at any cross section for a three-hinged parabolic arch subjected to UDL over whole span is 0. This is the concept here. Bending moment throughout the span for a three-hinged parabolic arch subject to UDL will be 0. Now we shall see other formulas. H is equal to WL square by 8H. What is H here? H is the horizontal reaction. Horizontal reaction is given by WL square by 8H, when W is the UDL for the whole span. UDL is acting over the whole span. Then we can use this horizontal reaction equation. H is equal to WL square by 8H. If the load is about half portion or any unkind of load, then we have to analyze in such a way. But in case the parabolic arch, that is three-hinged parabolic arch subjected to UDL over the whole span, then we can use this set of formulas. Now we shall move on to the next one. Y is equal to 4H by L square x into L minus x. So what is Y here? Y is nothing but a vertical distance at somewhere x. At some x horizontal distance from the from a support, what will be the rise? So that we can calculate using this formula. Y is equal to 4H by L square x into L minus x. So L, we know L is the length of the, or the span of the parabolic arch, and H is the central rise. And next is the NX. Nx is the normal thrust at x section. For example, say this is the section we are taking, then what is the normal thrust? That we can find using this formula. So here you can see this is the vertical force, this is the horizontal force, and the resultant is the normal thrust. So normal thrust will be acting at an angle of theta, that we can find using the resultant of forces concept. So these equations will be applicable for a three-hinged parabolic arch. Nx is equal to Vx sin theta plus Hx cos theta. Vx and Hx are vertical force and horizontal force at that section. That section we have considered. And similarly Sx. Sx is nothing but radial shear. So here radial shear is acting. So radial shear is given by Vx cos theta minus Hx sin theta. So this set of equations or formulas can be used only for three-hinged parabolic arch subjected to UDL. Now let's move on to the next question. A three-hinged semicircular arch of radius r carries a UDL over the entire span, which is W per unit run, and we have to find the horizontal thrust. So in the first two questions we learnt about the three-hinged parabolic arch. Now we shall move on to semicircular arch. Three-hinged semicircular arch. Here the question is, what is the horizontal thrust? Here the answer is WR by 2. W is nothing but UDL, that is W load per unit run. R is the radius of the semicircle. Here small r is mentioned, or we can use capital R. Now we shall see some more formulas for the semicircular three-hinged arch. Mx is bending moment at x section. For example, say this is the section X, then what is the bending moment at that section? We can find using this relation, minus WR square by 2 into sin theta minus sin square theta. So what is theta? For example, say we are going to find at this section, then theta is this. For example, say we are going to find at this section, then what is the theta? Theta will be this. So this is the theta with respect to horizontal, given by mx is equal to minus WR square by 2 sin theta minus sin square theta. But in case of parabolic three-hinged arch, the bending moment at any section will be 0, because that is a pure compression member. So that is why bending moment is 0 in case of parabolic three-hinged arch. But in case of semicircular shaped arch with three hinges, then moment at that section, any section, will be given by using this equation. Then when the bending moment will be maximum, when the theta is 30 degree. When the theta is 30 degree, say at around here, the moment max, that is maximum bending moment, will be minus WR square by 8, where R is the radius, W is the UDL or the entire span, and theta will be at 30 degree. This is all about the semicircular three-hinged arch. Now let's see more about three-hinged semicircular arch subjected to point load at ground. So instead of UDL, a point load is acting. Then how to find the parameters like moment at x section? So here moment at x section will be given by W by 2 into x minus y. W is the point load acting at ground, and x minus y. X is the horizontal distance from a support, and y is the vertical distance. How to find those things? X is equal to r into 1 minus cos theta, and y is equal to r sin theta. Y is the vertical distance at that section, and x is the horizontal distance. For example, say this is the section we are taking, then this will be x and this will be y. So at this x section, what is the moment? So that we can find using this formula for a three-hinged semicircular arch subjected to point load at ground. And in the same way, we have maximum bending moment. Here maximum bending moment will be occurring at 45 degree, but in the case of semicircular arch subjected to UDL, then maximum moment will be occurring at 30 degree. That is a difference. When point load is acting at ground, then at theta, that is at 45 degree, bending moment max will be there. That is given by minus WR by 2 into root 2 minus 1, acting at 45 degree. And similarly we have Sx, that is radial shear, as we have seen in the previous parabolic arch. Similarly here also for a semicircular three-hinged arch subjected to point load at crown, Sx will be W by 2 into sine theta minus cos theta. So these are the set of equations or formulas that we can follow for that particular cases. For a UDL case, we can follow this equation. For W at crown, we can follow this set of equations or formulas so that we can find the answer for bending moment as x section or maximum moment and radial shear. Now let's move on to the next question. A three-hinged parabolic arch is supported at different levels. So here in the previous three questions we see both the supports are at the same level. In case the both supports are at different levels, as we can see here, the support is at lower level and support A is at higher level. Then what is the correct equation or the correct relation from the given options? This is a different thing, supports at different levels, and parabolic arch and three-hinged parabolic arch. Option A is correct. L1 root h1 equal to L2 root h2, because it is a parabolic thing, so that is why x square by y is equal to constant. So in that scenario we will get this equation, so that's we can remember this equation so that we can get one height when all other three data are given. L1 root h1 is equal to L2 root h2. This is the case to find the level difference between crown and support. This is the h2 and h1, and L1 is the distance from the support and L2 is the distance from the right support. And when subjected to UDL throughout this span, when this type of arch is subjected to UDL throughout this span, then what is the horizontal reaction? H is given by WL square by 2 into root of h1 plus root h to the whole square. So this is the equation that we can follow in case a parabolic three-hinged arch subjected to UDL throughout this span. Now let's move on to the next question. This question is based on two-hinged arch. So a suspension bridge with a two-hinged stiffening girder. So a suspension bridge with a two-hinged stiffening girder means it is a two-hinged arch. So if a two-hinged arch is there, then that arch is either determinate or indeterminate to 1 degree or 2 degree, or it is not at all a structure, it is a mechanism. What is the correct option for a two-hinged arch? That can be either parabolic or semicircular, that we can see later. For a two-hinged arch in general, that two-hinged arch structure will be indeterminate to 1 degree. How? We can see in this support we have two reactions, one is horizontal, one is vertical, and similarly we have two reactions. So totally we have four reactions and we have three equilibrium equations in our hand. So 4 minus 3 is 1. So that is why that two-hinged arch is indeterminate structure to 1 degree. Now we shall see formulas one by one regarding two-hinged arch. We have already seen other things about three-hinged arch, when it is parabolic and when it is semicircular. Now similarly the case follows for two-hinged arch. For two-hinged semicircular arch subjected to point load at anywhere, that is W. What is the horizontal reactions? That is given by W by 5 sine square theta. For example, say a point load is acting at here and this arch is a semicircle one, then what is the horizontal reaction? That is given by W by 5 sine square theta. When the two-hinged semicircular arch is subjected to a point load. When the same two-hinged parabolic arch subjected to point load, then what is the horizontal reaction? 25 by 128 WL by H. When the point load is acting at crown, this is the thing. When the point load is acting at anywhere in that two-hinged parabolic arch, then separate analysis has to be taken to find H value. When the point load is acting at the crown level, then this is the formula, 25 by 128 WL by H. H is the rise. And for two-hinged semicircular arch subjected to UDL, for a two-hinged semicircular arch subjected to UDL, then H is equal to 4 by 3 WR by 5. And two-hinged parabolic arch subjected to UDL, then WL square by 8. This is similar to that of three-hinged arch also. So these are the set of things regarding two-hinged arch. Now we also have studied about the three-hinged arches. So we have completed the syllabus regarding arches. Now in this next video we shall see about cables. Thank you for watching the video. Hope you like this and share this video to your friends. Thank you.